The broadcast is now starting. All attendees are in listen-only mode.
So good evening everyone in the room in London, and good evening, good morning, good afternoon, wherever you are listening in the webinar. I think we've got something like 200 people registered to either listen to us live or catch up when they wake up, because I think the Australians at the moment are all tucked up in bed, so they'll be listening to this later on. So a very popular event tonight, and it's great to see so many of you here and have so many registered in the webinar. I'm just going to say a quick few words about the Energy Centre. So I'm Stephen Simons, for those of you who don't know me. My day job is Dean of Engineering, Design and Physical Sciences at Imperial University London, and we're about to start recruiting for staff to establish our engineering department. So watch out for the adverts in September. Previous to that, I was for most of my academic career at University College London, just down the road from here, and set up a low carbon innovation centre there. So the IChemE asked me to be the founding chairman of the Energy Centre, and for those of you who might not know anything about that, I'm going to give you a few words in there. So this is the timetable for today, a very quick intro from me, because I really don't want to take everybody's time up. And then Niall McDowell here is going to do a presentation of the report that we've commissioned for Q&A, and then we have a very distinguished panel, and I'll introduce them at that time. And then obviously all these events are always followed up by refreshments and networking, and we do that outside there, and you're very welcome to join us and continue this stuff. So the Energy Centre was launched in March last year. It was launched consecutively in Australia, in the UK and in Malaysia, those three countries representing the biggest areas of IChemE membership. I was in Brisbane at the time, so I was in the Brisbane office, and I think there were people here too. So, and it came about as a result of a survey that we did with the membership, and clearly there was felt a need to have a body that's come up with some sensitive opinion from the membership on energy-related climate change issues, and to provide evidence-based chemical engineering perspectives on those level energy challenges for government decision and policy makers, for industries, and for our membership as well. So that's what we do, and we're really picking up speed now. It took some months to get agreement on what we're going to try and do, and now we're fully up and running, and we've held several events like this. They've all been really popular, not only in London, but of course overseas. We've had events in Malaysia, we've had events in Australia, we have one planned coming up in South Africa, which is featuring the board this year today, organising that. We've got events happening in Singapore as well, all under the Energy Centre in as I said, we have a board, so I'm chairman of the board. We have some vice chairs, the names you might recognise as past presidents of the IChemE, and Niall himself sits on our board. We also have a leadership forum, which I'll explain a little bit about in a second. And our board members cover not only the geographical coverage, but also the energy-related SIG. So all the energy-related SIG are represented on the board. So, for instance, Toby, Chancellor Wheel, is the chair of the oil and gas SIG. I won't go through all the names, and we have our virtual board meetings every 2 months, because everybody's from different parts of the world. So we're covering the 5 main priority areas that the membership came up with in the survey, and one of those is CCS and what we should be doing in CCS, and what we're doing here to help us. That's what we talk about today. But we also rely on our membership to provide us with expertise. It's not just we don't want to be board members writing these reports. We look for expertise amongst our membership and amongst the wider community as well. And that's what we call the leadership forum. So if you are interested in being involved in the Energy Centre activity, please let us know. There's an email address there, and you can play a direct role in developing our green and white papers and other outputs. think that's probably enough of about the Energy Centre, but I'll be staying behind tonight, so if anybody wants to ask me more, you can. And as an example of what we do, tonight we're talking about the future of CCS, and that is an IChemE Energy Centre green paper that Niall's been working on. As part of that, we hope to get together this CCS Forum, who are here tonight, some of them in the audience. And that forum is a group of academics, a group of experts from academia, industry and government, supported by IChemE Energy Centre, but also the UK Foreign and Commonwealth Office, Royal Society of Chemistry and Imperial College London. And we're going to be hearing more about their report. I should say that I think you've got copies of the summaries of the reports, but the main report will be available to you after this event. There'll be a link sent so that you can download the full report. So there's no need to scribble those notes. So without further ado, I'd just like to introduce Niall. So Niall McDowell is a chartered engineer, of course, and secretary of the Energy Centre. He's been working on low carbon energy problems for 10 years. He's at Imperial College, lecturing in energy and environmental technology. His main research interests on mathematical modelling of dynamically interacting systems in the context of low carbon energy generation. He's given expert advice to WAD, DEC, EIA, ETI and JRC on a wide range of subjects, including energy efficiency, waste heat recovery, CCS and CO2 utilisation and bioenergy. So he's a perfect person to talk to us about the future of CCS. So over to you, Niall, and you put this on.
Does that work? Okay, great. So thank you very much for the kind introduction, Steph. And so I'm really thrilled to be here. I think 200 people, both real world and virtual, is possibly the largest audience in front of which I've ever spoken. So that's nerve-wracking. I think before I kick off, I'd like to really just thank and acknowledge the members of our panel who've come along this evening. They both participated in this forum back in February and also contributed to the review of the report that we produced. So what I've really tried to do is, both in the report that we produced and also in this presentation, is sort of mediate consensus view. So this is not my perspective. This is the consensus view that came out of this forum that we had back in February. So this is pretty much why we're all here. So what you're looking at on the y-axis is the net CO2 emissions from fossil fuels and cement. So this is all anthropogenic CO2 emissions going back from the 1980s, and we've got time on the x-axis. The dark curve is history, and it's all going up. And then out of the COP21 Paris Agreement, the aim was to limit climate change to something like between 1.5 and 2 degrees. So this is down here. So this is a really huge level of ambition, but particularly when you contextualize this against the stated aims of all the countries going into the COP agreement, the INDCs, or what are now called NDCs. This would get us to about 3.5 degrees. So this is sort of for the current level of ambition, around about 60 gigatons a year. So that's nowhere near what's needed to happen to meet the as much as negative 20 gigatons a year by the end of the century to get us to 1.5 degrees. So COP was great. It set a huge ambition, but current commitments are in no way commensurate with achieving it. And the way I like to start these kind of presentations is in somewhat of a discursive format. So I'm unashamedly stealing this slide from Professor Rob Sokolow. He presented this at the Gordon CCS conference last year in Massachusetts. And it just breaks the world down into four very simple views, according to the answers to two questions. Firstly, are fossil fuels hard to displace? And secondly, is climate change an urgent matter? So what I'd really like to do right now is take a quick straw poll of the room. So is there anyone in the room who thinks that fossil fuels are easy to displace? In other words, you'd be no. And do you think that climate change is not an urgent matter? Does anyone belong in this top left quadrant? One person at the back. Or two people. What about fossil fuels not hard to displace and climate change is an urgent matter? Anyone in the bottom left-hand corner? 1, 2, 3, 3.5? 3.5. Okay, top right-hand corner. Fossil fuels are hard to displace, but climate change is not so urgent. Anyone there? One? People have already had their hand up. So it's okay. So there's a couple. And then the final one. So does anyone think that climate change is urgent and fossil fuels are hard to displace? Okay. So, and again, I'd love to claim that this is my idea, but this is entirely Crocodile's insight. So you've got one worldview that you can nuclear renewables, no problem. Or fossil fuels are easy to get rid of and climate change is important. So this is sort of very much environmentalism. Many people, is this working? Many people, okay. In the fuel, many people live here. A lot of the public is in this area, and this is it's only in one of these combinations that CCS becomes a kind of a coherent discussion. You have to believe that fossil fuels are going to be hard to displace, and that climate change is important, and that's quite a lonely place to be. I think that this is quite instructive as well. So this is going back in time, looking at different projections since the 1970s of how much renewable energy people thought would get onto the electricity system. This is in the United States versus what actually happened. Okay? So in other words, things change, certainly, but they change slowly. And it's this that then in turn gives credence to images like this, where in the year 2000 we had something like more than 80% of our energy, primary energy, came from fossil fuels. But, and this is Mark Ducard's from UBC in Canada, there's still good reason to think that by the end of the century, more than 60% here of our primary energy will come from fossil fuels, despite the fact that there will likely be a significant expansion in the amount of renewable energy that we use. We'll still likely use an awful lot of fossil fuels. So in that context, then, not having CCS, carbon capture and storage, is uniquely costly for meeting these targets. And so this is where taken from the IPCC's reports, where they find that first of all, most models don't actually solve in the absence of CCS. So in other words, it's not possible to meet the target. And for those models that did solve, the cost of reaching the target was upwards of 138% more expensive. So in other words, it may not be possible to reach a 2-degree target without CCS. And if you can reach it, it will be a lot more expensive than if you did have CCS. So that's sort of what brought us to this forum in February. And as Steph said, I've been working on sort of CCS-related issues for about 10 years. So the question that I had was, well, what have we learned in the last decade, and what should we sort of focus on next? What are the next things that we need to think about? And that's sort of what I want to communicate with you. So to address this fairly wide-ranging question, I would very likely call a really great group of people from all over. This is the photograph, so it actually did happen. I'm just making this up. And this included people from Australia, from the United States, from Canada, from Asia, all over Europe, and also, of course, all over the UK. So I think that we can argue that this report and this consensus really represents a kind of global expert opinion. And again, it's really probably backed up by the CCS and UCC. So, key areas for discussion that we'll go through. So with power sector and flexible CCS, so that's how CCS will actually interact with the electricity sector. The role of CCS in industry. The role of new materials for absorbing CO2, so solids or solid liquids, membranes. Negative emissions technology. So you'll recall the first one of the early slides, we saw that by the end of the century, we're looking at taking something as much as 20 gigatons per year out of the atmosphere. So you can contrast that with the current net emission of positive 35 gigatons. So the negative 20 is extremely big. It's a lot of work and an immense amount of negative emissions technology. Of course, CO2 transport is important. You don't get from the power plant to the industrial facility to store it, but that's great for the life. And then CO2 storage, mitigate climate, but also utilization in the form of perhaps CO2 EOR, and also the conversion of CO2 to chemical products and plastics. These were all discussed, and this is what I'm summarizing. So, one of the first things that we thought was very important that we developed going forward, a computational framework to understand the dynamic interplay between scientific and technological advancements, and in turn the impact on the power market and the broader socioeconomic consequences of the former CCS. So, for example, that could mean if I develop a new material, a new molecule, a new membrane, how will that affect the performance of the process in which I use that material? And then if I have this new process, a new CCS, how will that operate in a power market? Will it be sufficiently responsive to the needs of the electricity market, and so forth? So we really need to be able to trace from the molecular level right the way up to the whole system point of view, and then back down again. We need this framework to address these critical issues. We also need a better way to rapidly screen new material for CO2 capture. I think probably between 2011 and 2014, there were something like 2,500 new method organic framework material reported as being promising for CO2 capture. A very, very small fraction of those have been simulated in the process performance context. So from an engineer's point of view, the chemists are doing fantastic stuff in the lab, but we don't have a framework to go and understand, are these the right material for the new conditions. So by developing this framework, this will help debottleneck the development of step change material, and also, and I think this is particularly important, of reducing and eliminating false hope. So when you see papers in Nature taking breakthrough material, well, actually, yeah, we can put this into process engineering context, it turns out not so much. And that's really important to speed up progress. An updating of benchmarks. So I think everybody in the CCS industry knows that the benchmark for performance is 38% MEA costs, 30% of the power plant's output, and so on and so forth. That might have been correct about 20 years ago, and it was certainly correct-ish when I started. It's absolutely not correct today. So the industrial best practice, so I think that's Shell's can salt technology, in the range of about 2.3 gigajoules per ton, and other materials like calcine, KS1 salt, and denatite salt, they're in a similar range. Last week at the Faraday CCS discussion, Professor Gary Rochelle from the University of Texas also presented a process where the energy content is 2 gigajoules. So this is a very substantial number. This is the real benchmark, 2 gigajoules. That's what we need to kind of be cognizant of this. So when somebody comes along with material, these are the benchmarks against which they need to compare. The point of CCS is carbon capture and sequestration, storage, it's climate change mitigation. And that's the reason that we're doing this. So this implies to me and to the group that permanent storage is slightly delaying the emission by 10 years or 50 years or even 100 years is not sufficient from the perspective of the climate to mitigate climate change. Therefore, de-risking of CO2 storage infrastructure along the way and characterization of suitable geological structures is really, really urgent, and perhaps more urgent than the development of new capture technology, and in particular the Asia Pacific region, because of how much CCS is likely to be needed in this region to meet that region's particular problem. CO2 utilization via enhanced oil recovery, that's EOR. It's a mature technology, so this is something that's been ongoing in the United States in particular since about the 1960s. It has the potential to provide a near-term market-driven pull for the deployment of CO2 transport infrastructure. So this was actually observed in the first decade of the century, where owing to higher oil prices, there was an actual market demand for capture of CO2. This happened. So CO2 EOR is really useful because it does tend to happen at scale, tens of megatons. And this helps lead to the deployment of CO2 transport infrastructure. That's really useful. But it's not a panacea. So this, just because you can do a lot of CO2 EOR doesn't mean that it fixes everything. And it can lead to the next emission of CO2. However, there is some evidence to suggest that EOR, so oil derived from EOR, can displace oil derived from other sources like unconventional power cycle, which then leads us into a conversation about avoided CO2, which is also quite important in this space. The market for products derived from CO2 will likely to be very small relative to what's needed to be stored as part of climate change. So in the period from now to 2050, just 2050, avoid the emission of something like 800 gigatons of CO2, 800,000 megatonnes. Of that, depending on the year of the IU, CCS might contribute 14 to 20%. So that's still in and around 100,000 megatons. Current CO2 utilisation for products is on the order of 200 megatons, and might grow, if you look at what the global market is, might grow to say 657, certainly shy of 8. So CO2 conversion of products is small relative. As I mentioned earlier, in order to contribute to climate change mitigation, CO2 effect needs to be taken out of circulation from in human terms forever. Delaying emission a couple of decades, 50 years, as might be the case in this case, simply doesn't work. However, using CO2 can have the effect of materially reducing the environmental process. So, for example, if you use CO2 and displace a fossil in your environment, that's really good. Not necessarily for climate change, but for the environment. Efficiency is something that engineers are very familiar with when we talk about it. So we want more efficiencies to reduce the energy associated with deploying CCS. However, and this is another, this is something else that's been noted by the GHG program, is that the contribution of the new solvent to reducing the pounds per megawatt hour of CCS outputs is actually relatively small, and particularly, so we need to really focus on what reduces the pounds per megawatt hour cost of CCS, not just always thinking about better solvents. Given low fossil fuel prices, which is this one, the environment, and efficiency improvement at the cost of increased capital cost. So, for example, doing a lot of heat recovery, you increase the efficiency of the process, but you potentially make it more costly. This could actually increase import out of your process, and therefore make your system less competitive in the market. In this context, instead of focusing on simple materials which absorb CO2 and have a lower energy absorption, focusing on materials which have accelerated rates of heat and mass transfer, they may be quite promising. Decoupling the cost of power generation from industrial processes with CO2 capture and the requisite CO2 transport infrastructure is key. So what that means is that initial efforts, for example, the white roads and the projects, they lump together the development of the capture plant, the power plant, the transport plant, so it was all done together. This translated into one final cost, which was ultimately too hard for government to bear. This doesn't take into account how make better use of that infrastructure in subsequent projects. And that's a problem. So it leads to initial costs. Initial project costs can be significantly inflated relative to the net potential over subsequent cost reduction once infrastructure costs are shared. So kind of understanding how to take advantage of this is something we need to do better. The role of electricity markets in the development of CCS technologies needs to be carefully evaluated with particular attention to the way in which CCS power plants will interact with electricity markets. So, for example, in a UK context, where we're going for a lot of renewable it's unlikely that CCS plants will apply base load generation. So they will need to try and be designed to put that in mind. If you're in another country where you don't have such which greater amounts of generation, this may not be the case. So we need to think about what we're doing and where we're doing it. That's on that near term, so near term is sort of that near term targets, they're not going to be medium, so medium term with long term targets. So for example, if we COP21, within a settlement model, indicate that vast amounts of bioenergy and CCS BECCS will be required to provide emissions. Obviously, BECCS cannot exist without a mature and de-risked CCS industry. So greater insight into the role of BECCS within the power sector and the industrial sector, as well as with having emphasis on the water private energy nexus, is required. So to sum up, to conclude, as Steph mentioned at the beginning, the Commonwealth is very gentle to this workshop because I think it's coming together experts from all. They're also a key part of what's called emission mitigation. This is a very large emission mitigation right now it doesn't explicitly include CCS as a technology of interest. This is something that we should have. And then there's also a lot of interest in understanding whether the oil and gas collaboration of the OGCI and also perhaps the CN will take a lead in studying the exploring the field of geological and we're finding an effort to investigate collaborative activities with the Canada's oil sands innovation and implementation plans, CN, and the OGCI within emission innovation initiative would be a broad approach. So with that,
We have some time for questions, that's right, isn't it, Alex? Yes? Do we have a roaming mic?
We do. And you have to hold it up to your mouth so that our webinar listeners can hear us clearly.
So we'd like to open to the floor and to people listening in the webinar for questions directly to Niall about his presentation. If you're asking a question, could you just state who you are and your affiliation to us, please? So any questions? Okay, so
They're always on the other side of the room. Bear with me.
So we'll start with Jim and then the gentleman behind him.
We're getting there. Here you go.
Hi, good afternoon. Jim Petrie from the University of Sydney, but also from the Western Cape Government in South Africa. Niall, it intrigues me that the NDCs are where we're hanging our hat at the moment, at the same time relying on the private sector to actually do the grant program. But it's not in any way explicitly stated in the outcomes of the study how we more effectively get public-private partnerships together to deliver. Could you expand on that perhaps?
I'm going to probably pass this to Wilfred when we move to the panel. So I think just during this forum we were quite conscious that we were a group of scientists and engineers, and we tried as best as far as possible to restrict the conversation to scientific and engineering questions, so to technical things that we could address with confidence. What you articulated is, of course, a key question, but it was not something that we wanted to focus on in the technical forum that we had sponsored by the Royal Society of Chemistry, the Royal Medical Engineering. But I think that's a really good question, and I think Wilfred might want to. Sure, yeah, if you're okay.
So Wilfred Maasbach. So I'm thinking that's a very good question. Because this is really about public and private partnerships. So it is specifically around CCS, and we know that we can build this together. But the need for market mechanisms, it's enable private companies to build and add private partnerships. There and it is important to develop the utilisation programs and the but the outlook that work was clear at the beginning of this project. So it's now specifically working with public and private partnerships to develop the market outlooks, and it's creating the stability and this they recognize that this is a significant industry with significant emissions. That way you can plan those plans. So those plans are also quite substantial.
Okay, so we need to be careful we don't stray into the sort of panel discussion, but are there any direct, and thank you, Wilfred, and perhaps we can expand on that later on. Direct questions to...
Yeah, I recognise very much the value of your scouting calculations. One of the calculations that I think is this, that if you take Drax as a coal station, it's the largest I know now, it's converted some of its boilers under subsidy to biofuel for ships. But let's stay with that size. Drax is 7% of the British chemical output. That's about 12 gigawatts. And Now, if you, and that requires something like 8 million tonnes of coal a year, which in turn generates about 27 million tonnes per year of carbon dioxide. So I've taken this as a measure of what would be an effective use of CCS. It would have a significant impact on emissions. But if you take 27 million tonnes of CO2 and you compress it to liquid form at around 50 bar, which gives you a temperature of around 10-15 centigrade, then you come to 18 million cubic meters of liquid CO2 per year. And that occupies 9,000 kilometers of 1 meter diameter pipe, which would be very good for the British steel industry and others, but it hardly seems a practical solution unless you've got some gigantic aquifer, per annum by the way, to absorb these huge quantities of carbon dioxide in liquid form so that you get the minimum volume taken out. What have you got on that?
So I think if I understand you correctly, that was basically a question of do we have sufficient space to store the amount of CO2? So I think was it GCCSI or the Steel Institute in the United States presented some evidence that indicated that we would sail in aquifers between 9 and 11,000. Sufficient storage space for between 9 and 11,000 gigatons of CO2 adds to understorage conditions, which are about 110 to 150 approximately. And then you can contrast that with what we might expect to need to store, which is only over 100 gigatons of CO2. So again, we need to store a lot, but there's more. Yeah, but there's more. No, that's good. So there's more than enough storage space. I mean, that's a non-issue.
But we're talking about Britain, I think. At least I'm interested in Britain. And,
okay, so in that case, then the ETI study again showed that the UK actually is particularly proportionate when it comes to storage, potential storage infrastructure. There's a very significant amount of pore space available offshore, and so yeah, I mean, there's a very significant amount of potential storage space offshore. So again, that is not.
Perhaps that's well, we've got one more question directly to the report, and then we'll have the panel discussion, because clearly there's some major issues being raised already which the panel needs to get hold of. So, yeah, sir, John, there, and then we'll finish with questions for that. And then we'll go.
John Gibbons, UK CCS Research Centre. It's really a sense of the process as much as the report. So the question is, what level of consensus do you think you got, and what to you was the most interesting variation in opinion amongst the expert community? Because I don't think that will be in the report, but it is quite interesting to some people.
Well, since you were there, John. Yeah. Well, so I think that there was a surprising amount of consensus, given the breadth of the discussions and the duration of discussions. CCS is an inherently broad area, so we spent some time talking about molecular thermodynamics, quantum mechanics. We spent a lot of time talking about stove chemistry and saline electrons. So it was very, very broad, but in general, I think the level of agreement was, in most areas, significant. I think that the areas of most lively discussion were around negative emissions technologies, direct air capture in particular, and CO2 conversion and utilization. Does that answer your question?
Okay, thanks, Niall. Well, a very interesting report, and a lot for us to debate on now. So thank you very much for your presentation. Perhaps we can thank Niall again for that. So I'd like to invite the panel members to come and sit with me and share their thoughts on the key issues of what we need to do, or what are the next steps and actions we need to take as a community if we are to see large-scale CCS, and maybe you want to take my seat, sir, and I can move aside to the front somewhere. Let me just. I'm not going to read bios and things because, as you can see, it's a large panel and that will take take a long time. So I'll just go through my list here as I have them. We've got Andy Boston. Make yourself, who's Andy? Andy's here. So Andy is an analysis team head of Energy Research Partnership. Wilfried Maas, you've heard from already. He's the general manager of CCS Technology Shell. John Gale, next to him. Some of you might know, General Manager of the IEA Greenhouse Gas R&D Programme. Rupert Wilmoth, who is Head of Energy Government Office of Science. Guido Behneshti, who is the Senior Advisor of the Global CCS Institute. And Theo Mitchell, who is Policy Manager of the Carbon Capture and Storage Association. So quite a prestigious panel of, dare I say, CCS advocates. So, perhaps each of you could take just 2 minutes to give your views on what next steps and actions we need to take as a global community to realise these negative emissions that Niall was talking about. Shall we start, Guido, with you from that far end, and then we'll work our way to this end? Yeah. So you'll need to use my map. Just a couple.
Yeah, so you mentioned negative emission. So I think we can basically only talk about bio-CCS will about negative emission. There is direct air capture, which is probably where you consider something that can make an impact. Is this working? Well, and where the opportunities are. I think today the opportunities are really in the industrial sector, and this is not just because industry is part of the whole industry that has quite a big contribution to emission, but I think the opportunity there is that industry is now recognizing that they have to do something about decarbonization. So I think they start to get interested in CO2 capture, and maybe at this moment they are more looking at CO2 utilization than CO2 capture. But so I really see an opportunity there to work together with the industry and to start, how to say, define routes and roadmaps on how this industry can contribute to decarbonization, without forgetting the importance of CO2 hubs and cluster, and also other, let's say, ideas like hydrogen networks that are now getting into media because they are getting more interesting. So I see opportunities more into these kind of things.
Okay, thank you. John.
Okay, a couple of points. I think.
Can you keep the mic?
Sorry. I think in the UK we are geologically well off, but geographically constrained because we have all our storage resources, just as you pointed out, in the middle of the North Sea, and there is a distance that this material has to be transported out into the North Sea. To do that cost effectively, I think is key to unravelling CCS in the UK. We can do capture, we've demonstrated all that. The key is developing the transport networks to get the CO2 out of the point where it can be stored. So we need policy measures and incentives, and that's not just UK, but that's a European-wide issue. And that also fits large parts of Southeast Asia, where countries like Japan, Korea don't have the geological resource near shore, they're going to be looking offshore. So this whole development is infrastructure. How we do it, how we incentivise it, what policies we need to bring that about, is very important. And Niall mentioned one issue that's been talked about that really hasn't had a lot of traction is, do we need in the UK or in Europe a national storage company? We take that issue away from individual projects because it had a blindingly bad effect on the competition projects. So we want to de-risk the financial problems of some of those in the future. Negative emissions. Negative emissions is the big buzzword now, and utilisation is the similar thing. Niall put up a slide which sort of talked about negative emissions with the energy, water, nexus. But to add on to that, you also have to think about food, sustainability, biomass nexus. It is a multi-nexus choice. It's easy to talk about, but we have to bring that to them. We have to put large quantities of biomass into the marketplace without affecting food production, because that's crucial. We've got a growing population that needs more and more food. So we have to, I think, put a marker around bio-CCS in terms of it's a great concept, but a lot more thought needs to be put into the whole production side of the biomass production. Another quick one, utilisation. Everybody is interested in utilisation. Many people see, especially around the world, it's hard to talk to the Chinese, the Japanese, or some of the others or the Indians without this word utilisation. It's in the mentality, don't throw waste away. Wonderful. But you also some sort of side about it, yes, it's not going to do a lot. And if you look at the main products and the way CO2 is utilised at the moment, the biggest use of it is in beer. As soon as you put the top off the back can of beer or a bottle of beer, the CO2 is gone. It's not permanent. So you're talking about very short-term storage. We need to get to a product that has long-term storage potential as well. Not just minutes, not just the odd year. A wonderful project came talking about in India recently, baking soda. Wonderful idea. We can actually use this to make baking soda. You add water to baking soda, what do you do? Yeah, you make a nice product, which is nice leavened bread, which blows up beautifully. Where's the baking soda gone? Where's the CO2 component gone? It doesn't compute in my mind all the time. It has to be worked through. And we can't, I'm afraid, as much as a lot of people want to, get away with this disconnect that we will continue to use fossil fuels in many regions of the world. And we have problems in those parts of the world with air pollution. CCS is a project, it's a complex system, but it actually solves two programs. It's a win-win solution. Because you have to take out the pollutants to capture the CO2. But both a climate mitigation and a air pollution solution as well. And if you think of it in those contexts, I think there's a lot of traction that will actually make governments start to think about not using fossil fuels in a unabated, not think about using them inefficiently, but actually use them for the benefit of the population as a whole and their own exchange as well, using them for healthcare and education.
Steph, before we go on, our online listeners are telling us that this microphone that I'm holding is better than that one. And here's a tip. In order for people online to hear you, if you hold it on your chin like this, then they'll hear every word you say.
Okay,
Just a couple of minutes, please.
So I think the first one is this technology is ready. So you can build it and you can just operate it. We have in Shell, with the support of the Canadian government, they built a test project for about 800 million tons of CO2. It's just another process unit, just another pipeline, just another well, and that subsurface, just like subsurface, needs attention. So this industry can also piggyback a lot on existing competences that are available in the chemical and in the oil and gas industry. So to get this going, you need to have effective market mechanisms. And I think the focus need now to be on getting the world into this, yes, fossil hard to replace, yes, climate is an issue, don't look to the coming 10 years, but look to your whole forward targets or objectives of 1.5 degrees and create longer-term stable, effective markets. As John already highlighted, one element that is key
is recognizing that in the end storage will be a public utility, so that there is a role for governments to set up those market-making companies, and specifically because there is so much cost reduction possible by clustering those storage network infrastructures. And the next thing I would like to highlight is that though we can build these plants, and they will be a chemical engineering's dream, and they are already as we are, that there is significant potential to make this much more efficient. As Neil already highlighted, just look to better contacting equipment, cheaper contacting equipment, look into other adsorbents. So this industry, when it will start up, they will definitely have a lot of improvement to make, and that improvement needs to be made to make it cost effective, and to reduce the cost of this technology further, to maintain its affordability going forward.
Okay, thank you. So,
thanks. Just to be clear, I mean, although personally I could describe myself as a CC advocate, in my role I have to be impartial and neutral. My role is to help ministers across government and policymakers understand the options that are available for a whole range of technologies across the energy spectrum. And I think we've seen in government with the cancellation of the CCS competition, kind of recognition that CCS was not affordable in the current state, but on the other hand, there was also an acknowledgement that if we are meant to kind of reach our climate change goals, that CCS is probably going to be likely at some point in the future. So there's a dichotomy here, and there's a kind of a role of the CCS community is very important to help resolve that dichotomy in government. In government, of course, we've had a lot of changes recently. We've got a whole new set of ministers, including the new Prime Minister. We've also going to have Brexit in some shape or form. What that is, we don't know yet. But we can say that there's probably going to be a slight movement of our eyes of government slightly away from Europe, perhaps, towards the rest of the world, North America, Asia Pacific. That's important. And so I think the role of the CCS community here is to acknowledge where we are on the political landscape. We will get to hear more about the ministers and their views in the coming weeks and months. Listen to that, acknowledge the political reality we're in, and help government come up with suggestions on how CCS can be effectively deployed for the UK, taking account of the kind of where we're looking at. Industrial strategy is going to be particularly important. In fact, the new department has the name industrial strategy in its title. I think that's a fairly clear signal there. So my role is to help translate the information that you're providing to policymakers and ministers. My role is a transmission mechanism, and that's why I participate in these things. It's very interesting hearing what the experts say. You come up with good ideas, how CCS can be taken forward, and I can help transmit that to policymakers and ministers, and we can hopefully make this technology successful in the UK. Thank you.
Okay, Theo.
Yeah, thank you. So I think firstly it's important for me to say that I feel very privileged to be here because I'm most certainly not a chemical engineer. I'm midway between a biologist and a social scientist, so my remarks, as you might expect, focus more on the commercial delivery, the industry side of things, and the policies and the regulations that might help CCS be deployed. I think that's the first point I'd like to make, that I think in order to, we're talking about what do we need to do to deliver CCS on a global scale. Well, I think we need to focus on deployment. It might sound obvious, but there's this real myth, I think, around CCS. When I go and talk to politicians and policymakers, there's this myth that CCS hasn't really progressed and it's unproven and we haven't really done anything in the last 15 years. And I think there's a real need to challenge that view and be clear that actually we've got 15 operational projects now, we've got 7 more under construction globally, we've got CCS demonstrated, I think, across all the key emitting sectors now. Slackness stored 20 million tonnes of CO2, Boundary Dam's delivered its millionth tonne of CO2. So these, to a large extent, these are actually proven technologies now. We really need to focus on deploying those commercially. And I think it's important that we focus on the lessons that we've learned and how far we've come in those years. So in the UK recently, we've just completed an exercise looking at the lessons learned from the CCS competition projects. So we've already heard about the storage appraisal work that's been done by DEC and the ETI. I think we're a long way down the line now, and we really understand what the challenges are. And fundamentally, for me, that boils down to we need to create conditions for investment. And I think there's two aspects of that. One aspect is in terms of markets, and the other is in terms of rebuilding confidence within the industry. And I think in order to deliver that confidence and create those markets, we really need to have a clear sense of the role that we expect and the role that we want CCS to play in terms of decarbonisation moving forward. So, do we want CCS to provide baseload power? Do we want it to provide flexible power? Do we want it to decarbonise energy-intensive industries and process-related emissions? Do we want it to help deliver hydrogen, low-carbon hydrogen production, and deliver decarbonised heating and transport? I think each of those sectors actually will require a different set of policies and solutions in order to deliver CCS, in order for CCS to fulfil that role. I think beyond those immediate kind of sectors and the mechanisms, market mechanisms that are needed to invest there, I think, echo the points that others have made in terms of this is really an infrastructure challenge as well. The one common thread across all those different applications of CCS is the need for permanent abatement solutions, particularly CO2 transport storage solutions. I think what we know now is that actually, by and large, these are commercial challenges to delivering this at scale now. And I think when we look at storage, we see the need for appropriate and investable levels of financial securities required. We need to cap, or we need to have predictable and quantifiable liabilities relating to CO2 storage and monitoring and verification periods. And we really need to address this issue of cross-chain risk and the exposure of different parts of the CCS chain to the commercial and technical risks in other parts of it. So how do we move forward? I think Jim made the point about public-private collaborations. I think that's going to be absolutely key, certainly in the UK. We need to address the commercial risks, and we need to tackle the perception that CCS is unproven.
Okay, thank you. And Andy.
Okay, like Rupert, I would say I'm not a CCS advocate. I come, not even an expert actually, I come from a whole systems modelling perspective. And my background is in the power industry, so most of my remarks will be about CCS for power. The first thing I'd say that you need to recognise is that to decarbonise a power grid, it requires firm low carbon plant. So you can't decarbonise a power grid with intermittent renewables alone, or even intermittent renewables with storage. You've got to have some firm low carbon power plant there. And if you realise that, you then all of a sudden realise that CCS is not competing against wind or against PV, but there's only a small number of technologies that are low carbon and firm. And here in the UK, it really boils down to biomass, to CCS and nuclear. So that's the competition. If you look at other technologies, it's quite small. And also to realise that in some markets, it's the firm capacity that is tight, not energy. So a number of markets are awash with energy and prices go negative. But what is really tight is the ability to flick a switch and get power when you need it, when intermittent sources aren't there. The second thing I think the CCS community needs to do is push for evaluation of grid services that are not traditionally valued. So at the moment we value energy, and in some markets there is capacity is starting to get valued, but not everywhere. But quite often the grid services that we've had from fossil plants historically, like reserve and response and inertia and all sorts of technical services, have little or no value. And it's those that are going to be in short supply. So as soon as we see a value for them, we will see that the value of a plant that can supply it, like CCS, will grow. and therefore you've got to design your plant from the outset to deliver those. So a plant that is flexible in future ought to be a lot more valuable than one that can just run base load. And the third one, I think, is where the CCS community shoots itself in the foot sometimes, is to talk about LCOE, levelized cost of energy. That's a metric that favours intermittent renewables, tilts the playing field against plant that can deliver, technologies that can deliver firm power. So if you're discussing those sorts of issues and the economics, insist on talking about the value to the system that the technology brings and the value to the whole system. So it needs a whole system analysis. It's a lot more complicated because you can't just talk about one number, but you have to think about what's the value to the whole system of adding this technology.
Okay, I guess, Niall, you've already said your piece, so but you're quite welcome to join the discussion of the panel. So thanks, gentlemen. So we have half an hour left now for discussion, and that's hopefully going to be interactive. Clearly, one of the key issues coming out here is that there's a feeling that the technology is ready. It's the markets and the de-risking of the finance and attracting investors and the policy decisions that need to be made to support all that are the big challenges. So I guess I can sort of kick off really because we've been here many times before discussing these kind of things. I feel. So what is it that really is going to make that change? What is it that's going to help us make the next step and really see this happen? What I thought was interesting from the report was that there were some new ways of looking at things that were being suggested. Particularly, I put up this slide here about the way that the costs are looked at, because obviously first of a kind is always going to be very expensive. But once things are up and running, maybe there's makes it look more interesting. What does the panel feel is really the next step that we need to take? Let's say technology's there, and we've got a storage site. What is it that's really going to step us over that line and get us going?
Government to invest and build the infrastructure so that we can not just think about single projects, but multiple projects leading off it. I think that's been one of the problems. We've been thinking about individual projects, but we've got to think bigger. We've got to think about the big picture and lay in the infrastructure now to be thinking about doing 20, 30, 40, 50 projects, or even 100 or so between now and 2050.
So I think it is much better communicating climate change and the value of this technology as part of climate change to a much broader problem. The fact that there was no public outcry that the competition was stopped. There is a clear indication that people are either ignorant or don't see the value or are not connected to the cost of adaptation and climate change. Where there is abundant information available that the mitigation costs can be much lower. Where we need also to be cognizant that there is the actor issue that this is a global issue. And because if it needs to work through this Paris type of agreement to get alignment with all the different countries around.
So I think there was, you're asking a question about what's going to make the change, and I think one of the things that the real barrier to CCS, certainly in Europe, has been is it boils down to political will, really. And I think we are starting to see things change. So certainly through the new EU 2030 governance framework and the Energy Union and new NDCs and that sort of thing moving forward, we are starting to see actually countries take a longer term approach to climate change now. So they're not, instead of looking at the question of what's the cheapest way we can decarbonise to 2020, now people are starting to think about what's the cheapest way we can decarbonise to 2050, 2100, and I think that will increase the evidence base of CCS. Secondly, I think people are starting to look at certainly starting to look at decarbonisation on a more economy-wide approach, and I think that's going to be helpful for CCS. It is so many things to so many people, and I think part of the reason that as a CCS community we've failed to convince people about the value of CCS is that it's almost been a jack of all trades and master of none, and that, it can do so many different sectors, and yet policy making has been based on a sectoral basis. So power system decisions are based on dynamic dispatch models, and energy intensive industries decisions are based on whatever. And actually we need a more holistic whole economy approach, and I think we are starting to see that come through now. And then finally, I think Paris Agreement changes things as well. So previously we were looking at 2 degrees, now we're looking well below 2 degrees. If the IPCC thought that CCS was important for 2 degrees, then who knows what they're going to say at 1.5. So I think those underlying political drivers are changing. I think we will see a change in the level of response in response to that.
So none of you mentioned the carbon price at all. Any views on how the carbon price could perhaps push us along a bit?
The only piece that I wanted to chip in on was, I think we've had 2 bites of the cherry when it comes to competitions. I think government needs to perhaps learn what's required to make CCS investable. I don't think, and of course I defer to Wilfred's opinion here, but I don't think that's as simple as a carbon price. I think government need to understand, or we need to better understand, the sufficient and necessary conditions for these kinds of public-private partnerships that Jim referred to earlier to actually happen. And I think the way that we've tried to do it in the UK so far has been, we're going to first have competitions, because we don't pick winners. Then we're going to provide a grant, and that grant will have strings attached, because you don't get free money. And actually that that is insufficient to buy down the investment risk to make CCS investable. The things that make CCS difficult to invest in are business uncertainty, cross-chain risk, and uncertainty about the future. So government need to better appreciate the types of risk that the market will accept, and when they'll accept them, and help provide the necessary instruments to bridge that. That's not as simple as just a carbon price.
I think to amplify on those points, I think what needs to happen, as I was saying at the beginning, is that the CCS community needs to come up with an attractive proposition to make CCS go forward. And that proposition needs the minimum ask from government. Minimum, be that in terms of regulatory steps or financial help. And then, having detailed those asks of government, they need to show government how as many of the government objectives across the whole board of government objectives can be fulfilled from those asks that the CCS community is asking for. But that is what needs to be articulated very, very clearly to government, rather than just asking for £1 billion for another CCS competition.
I think that's the key bit, is the attractive proposition. I think that's what I was looking for. John, do you have a point to make on that?
I think the attractive proposition. If you look at the EU ETS, I mean, we all accept that the EU ETS has not developed the sort of carbon prices that people want to see to invest in low carbon technology. But a simpler policy option in the United States has been emission performance standards. I can't say that the emission performance standards themselves have driven down emissions radically, but you see in the last 4 or 5 years now, since the sort of introduction of the Clean Power Act and working up to the Clean Power Act, that CO2 emissions have dropped substantially in the United States. And that's quite a simple policy mechanism. It takes it away from government, in a sense, and puts it back on the utilities. And they've responded in the United States. But again, I can't rule out the fact that sort of a little liquid gas price in the United States has had a bit of an effect as well.
Okay, so thanks very much for that. Well, I'd like to move first to some online questions. And then we've got some questions from the live audience here. So, sorry? So online questions, Alex, please.
Okay. Okay. The first online question I've got is, we've had a lot of discussion about the potential for improved efficiency, but the suggestion is that this is not going to happen until plants are a realistic scale of size. And how do we go about incentivizing the development and deployment of CCS that clearly isn't happening at the moment? And I've got another question as well, so shall I ask that at the same time? Okay, and then the other question is, how far away do you think we realistically are from having CCS commonly practiced across many industries?
Okay, so John, are you able to answer both? Try to answer both questions, efficiency and how far?
I'll take the industry one. I mean, I keep hearing everywhere that industry is lagging behind in the deployment of CCS. The first industry project was Sleipner in the oil and gas sector. We followed that with Snøhvit, Insular, Gorgon. We now have in the hydrogen sector, oil refining sector, we have an air products project in North America. We've got Quest in Canada. We've got Tamako High in Japan. We're building projects in steel industry in Abu Dhabi, in the Emirates. Industry, we're pretty much showing that all the industry areas are covered with demonstration projects. So it's not industry that are lagging behind. Industry is leading, and I think we do have the industry areas covered.
So one comment I want to make is that to have a healthy R&D and also a supply chain improvement, you need a healthy industry. So there is this element around it. If you don't have the deployment, then if you stay with a few pilot plants 1 year each, you will not get this habitat which creates this focused questions and tinkering on one side, but also the fundamental science to create breakthrough technologies. So I think that deployment and R&D are very much related because they need each other and they can't work without.
Guido, can you perhaps comment on
I'm echoing here, but indeed what we need is deployment of these technologies. R&D can do quite a lot, and we have seen that in the last years there has been quite important development, and we still see technologies that are not new, but they let's say are now going to piloting and demonstration, and those can be really promising. For instance, like the alum cycle, or these fuel cell technologies. What is important is just to implement these technologies at the scale, at significant scale that is representative of how a full-scale system would work, and then we discover what is the real efficiency, and then by deploying more of them, we can also achieve cost reduction. So the key element is really we need to have these demonstration plans in place first, and secondly, I like to remind that R&D is really active, it's not stopped, so we can expect in the next year, I don't know when exactly, but we can expect to see new technologies with better efficiency, and I completely agree with Wilfried when he says that there would be some efficiency improvement, and I'm sure there would be some cost reduction as well. So I'm positive in that regard, that there will be important technological achievement in the next future.
I actually like very much in there Niall's comment about don't chase the efficiency tail, chase the cost tail, because you can add an extra 0.5% of efficiency and increase the capital cost by 10 or 15%. There's got to be a trade-off between what's best in terms of cash for your dollar, and I think we've got to look more at capex reduction than efficiency.
What about the question of when? I think the question of when will there be large-scale
Yeah. Well,
network CCS?
So let's take that one first then. I think echo John's point. I think out of the 22 projects that I referenced earlier that are either in construction or operation, I think 19 of those are on energy intensive industry. So industry is perhaps further ahead with this than the power sector. Now, how far away do I think it is from common practice? Well, basically, I think this boils down to investability and infrastructure. So if you look across the piece at kind of the broad characteristics, common characteristics of energy-intensive industries, they're highly commoditized, they operate in global markets, typically poor credit ratings, short-term investment cycles. Now, these guys aren't set up to make multi-million or billion-pound investments in infrastructure projects. They need access to that infrastructure, and they need support from both large-scale, predictable emission sources, and underpinned ultimately probably by government investment. So I think once we've solved that challenge, once we've got infrastructure up and running, and we've made CCS investable for industry, then you'll see it. So I think that's what I'd say on that one. In terms of scale, clearly improved efficiency and economies of scale will come from scale. But if we're going to deliver this, we need market instruments, political will, as I was saying earlier, and we need a predictable investment framework. So we need to move away from this mindset of competitions and more towards one based on collaboration.
I'll just sound a note of caution on chasing efficiency and cost too much. You have to ask what value of the asset is going to be at the end, and if you can spend a little bit more and make it flexible, your profitability, value minus cost, might be higher than if you chase down efficiency and capex to the last cent. When I used to work for the CGB, and then it was privatised. In the CGB, it was all about efficiency, and you used to have the station which had the blue ribbons because it was 0.25% more efficient than another one. As soon as it was privatised, that was all out the window, and it was about making the plant flexible and reliable, and they were the most valuable commodities.
Right. Big point? No?
Just to note that's on the efficiency point, because I think it is one that comes up again and again. Cryogenic air separation, so commercialized in 1905. Today it's about 25% efficient. From a minimum thermodynamic work perspective. Point to Shell, but it's kinds of CCS technologies that we're seeing today. Council investment, we're looking at about 43% efficient. Last week at the Faraday discussion, Shell presented that technology option to be about 50% efficient at the task of separating CO2 from an exhaust gas. So these, there's a limit to how efficient things can get. I'm not suggesting that we're out. We've plumbed the depth of it just yet, but we're pretty good. We are not that bad. That's it's important to kind of put these things in perspective.
Okay, thank you. So now I'd like to spend the rest of the time with discussion with the audience here. So there's a question at the front of the room.
On your chin, please.
Big chin. Hi, my name is Harun Makeretin from UCL. Just a quick couple of few points based on what I heard from the panel discussion. I think we mustn't underestimate public perception. CCS success will also depend on public perception. We didn't get that far with the demonstration plan, which were abandoned by the government. I'm pretty sure that if things moved on further, then there would be an additional obstacle regarding public acceptability. So it is something that mustn't be forgotten. The other thing is that it is, as John said, it's industrial clusters that we should be considering and cost reduction. And it is an interactive system. Basically, if you reduce the costs in capture, it has implications for pipeline. If you reduce the cost for the pipeline transportation, it has implications for storage. So it is a real overall approach. You cannot treat one and focus on one aspect without considering the impact on the rest of the chain. So yes, it is, you have to reduce the cost. There are very clever things that you can do in capture, you can reduce the cost of transportation, but each one of these attempts that you make will have an impact on the work cost. On coming to the government issue, we have a major challenge now with Brexit. UK academics don't have the necessary funds or the infrastructure to do the kind of things that we were able to do through European Commission projects. I myself led 2 of these. It would have been out of the question to be, for example, to be able to build a pipeline over, to do realistic scale tests in the UK within the time frame that we were able to do in the European Commission project. Storing CO2. I mean, we've had capabilities to have access to unique expertise across the world, unique infrastructure, and that is being taken away from us. So I really do encourage to focus on this, because we need to do something serious. We need serious money, serious infrastructure, and the research funding councils are not enough, don't have the sufficient funds to provide us the resources that we require. So we've lost that European dimension, which is a major issue. That's something that I would like encourage you to take back to the government and see if there can be some sort of solution where we can maintain activity. So that is the other point. Unfortunately, with the White Rose project, industry partners have had their fingers burnt twice already. People have lost jobs because they championed this cause and they did a hell of a lot of work, and the plug was pulled. So it is, remember that we need to gain the confidence of these people, to bring them back on board. Companies like National Grid, who were involved in this, I cannot see how we can bring these people back to the table again, considering what happened. So there is a lot of damage limitation exercise that needs to be done to bring these people back on. That's comments.
Any passion comments there? Any follow-up comments on the panel? Or John, the mic is...
I mean, you mentioned the whole issue about Brexit on scientific research. It's a key issue for government. I mean, it's not just scientific research, remember. We're covering right across the whole range of things, from agriculture to transport. A huge range of things are, at the moment, in the current status, have got a huge European component. And the point is, we don't know what Brexit means at the moment. There's a whole range of options on the table. But whichever option we do take in terms of government, all the policies that are currently got an EU dimension will have to be replaced with something else. So, I mean, I think the government's very much committed towards scientific research. So we're aware that there is a significant amount of funding that is EU related at the moment. And in whatever form the negotiations take with the EU, we'll have to come up with some policy to support scientific research. So it's something, I can't give you any answers. It's early days, but government is very, very much alive to those issues on scientific research. So that's all I can say on that point.
So I would like to resonate your point on public acceptance, and I think I would even change that it's not acceptance, it's something that the public really wants. So we have done on our projects a lot of stakeholder management, and what we learned both in Canada and also in Peterborough, that the local community was definitely supporting those projects after due consultation. But there is the specific elements that, if you look to the drivers, it's about specific jobs that they are there, but that the public at large is at this moment very limited in wanting to do something for somebody very far away in a very far future related to something about climate change. It's a very academic and elite discussion. So there is this explanation about what will happen to your life if you don't take action on climate change, which I think brings this element home to people that I want to support these kind of developments because I recognize that this is something we need to do as society together.
Yeah, I think public acceptance, awareness, or whatever it is sort of a little bit blown out of the water. We did a study, that's about a series of studies over the years that looked at the global knowledge base and awareness on most energy technologies. And CCS has been consistent over the 10 years that probably less than half of 1% of the world's population know anything about CCS, and if you ask them if they don't care, they don't care. And they don't care about energy personally, unless it really hits them locally, and that's where the projects come in. The other side of this is the big kickbacks in Europe have been about onshore storage. Wolf knows that well from the Barandrecht experience. The other big kickback was in Germany. They didn't want onshore storage. Europe has that one ideal get out of that box. Storage is offshore. And I've not heard anybody fighting back about storing CO2 offshore in any of the social research areas that we've been running. It's all been about onshore projects. And yet you go to the United States, no issue whatsoever, because they have a long-standing oil and gas industry which is onshore, and which they know that it, as far as they can see, it's just life perpetuation of an existing industry, which means continuation of their jobs, continuation of their lifestyle, so they have no concerns at all. I think it's in Europe it's an offshore versus onshore issue, and where you have got a big industry that that's already feeds into the community through jobs and finance, then it doesn't become an issue.
Another just final point on public perception. So I completely agree. Absolutely mustn't underestimate it, and agree that some of the issues that they've had in Germany are just testament to the fact that we cannot underestimate public perception as an issue. I mean, that said, I think it's really important to also recognise that the projects went through such a long process of engagement with the communities that they were involved in. So Peterhead did years of really great work engaging the local community around that project, as did the White Rose project, particularly around the onshore pipeline. So, National Grid were working for 4 years on the community engagement on that pipeline. And actually, a lot of those lessons are captured in the key knowledge deliverables, the KKDs that government have released recently on the project. So, I'll point you in the direction of those and say, take a look at those. The fact that there was so much engagement and so little notable pushback, particularly in the media at national level, I think actually should give us an indication that the UK public is probably perhaps more supportive of CCS than people sometimes give it credit for.
You do use the mic, John.
In Germany, the latest public outcry is actually against big high voltage pipeline transmission systems. They are reacting in the centre of Germany about having all the wind power and renewable electricity that is up in the northwest of Germany, having that transported into the country in areas like Bavaria, because it's blotting the landscape and reducing the value of their houses. So the country as a whole wants green power. Locals think about it very differently. And you think about some of the hurdles. There was a lovely thing in a newspaper recently where 50% of the population in the United States of America don't believe climate change is real, because they believe in an omnipotent being, and he controls the atmosphere, so there's no problem at all. He will sort it out.
Okay, I think we've got a couple of questions at the back still. Do we? Yes.
Yeah, we do. Can you hear me? On my chin. Malcolm Harrison from a company that you've never heard of. I worked, I think, about 15 years ago on the evaluation of a carbon capture and storage project, the one up at Peterhead that you've been referring to, DF1 as it was at the time for BP. This will sound harsh. I can't think of any other way to put it, though. But the conclusions that you've come to and the questions that I've seen this evening are not enormously different from the conclusions and the questions of 15 years ago. Now, I heard one thing this evening that actually quite surprised me, which the handsome gentleman in the blue tie mentioned, which was that he said that the carbon capture and storage community should communicate to government in a clear way what it was that they needed in order for carbon capture storage in the UK to become feasible. Now, I was surprised that in 15 years they haven't done that, but I guess they have. Does it sit within the mandate or the remit of the IChemE Energy Centre to take advantage of that opportunity and make that clear, concise communication to government?
Sorry? That's something that we are here to discuss.
It's just I'm biased because I think in everything comes back to government, and it's so interesting how with the questions tonight, it comes back to carbon pricing or government subsidising this or government subsidising that. But if we're not communicating clearly to them, how can they
it's David.
make a decision?
Did you say David?
Malcolm.
So Malcolm, yes. So what I've circled here on my big take-home message that I've got as chair of the Energy Centre is again from the attractive guy with the retired. We need an attractive proposition with minimum ask from government, which is probably the same statement that we're referring to. And that to me is perhaps yes, where we as a community of chemical engineers can provide that insight and try and focus on something which, because as the panel said, and it's been probably more than 15 years where we've heard similar things, just seem to be still rather broad and jack of all trades. I think somebody said we really need to focus on something that really will excite investors, excite public, and excite the community. So I think to me that is one area which I want to look at as the Energy Centre. Yeah. What about the guy next to you who's got a question as well? And then we've got another one here further in. You next.
Thank you. My name is Adekola Lawal. I work for Process Systems Enterprise. I have a number of questions. I'll try and keep it very brief. My first question is, does CCS work better in some places, some regions, some parts of the world? I'm wondering if we should probably be looking at the lower hanging fruits and focus our efforts on those areas. Probably an idealistic view, but I think, for example, in the UK, I think there's quite a long way to go before we can actually convince developers to invest in CCS here. The second question relates to the question you raised earlier. Why hasn't CCS taken off? And I think it's probably related to the project finance, and not to go over this point over and over again, but I think it's worth raising the fact that it's challenging to actually see the clear contractual agreements and clear contractual arrangements that will make CCS attractive in the private sector. And there's so much dependence on funding from government. I think the challenge that we should face now and we should address now as engineers is how we can actually address this issue of project finance. I think project finance depends greatly on the contracts that will be put in place and how the form of those contracts when the project starts running and how things will pay for themselves.
Okay. Is 2 questions enough to start with? Yeah?
Yes, for now.
Okay. So, are there any low-hanging fruit? Is one question, and the other question I think we've covered, but maybe this issue of contracts and things is something you might think.
Yeah, I want to take the first question and the second to somebody else. Yeah, there are low-hanging fruits, and absolutely there are places where it makes more sense to do CCS. I think in Europe, here in the north of Europe, we are in a perfect place because we have storage, and we have enough storage, we say today before when Neil was presenting. And we have CO2 emission points that are, how to say, they are condensed in single places. We take, for instance, Teesside or Rotterdam or Antwerp. Those are all industrial clusters where makes complete sense to make CO2, to capture CO2, transport to a storage offshore, very probably, but also maybe utilize the CO2 as well in the nearby industry. So there are also synergies that you can have by having industry in the same place. So when you have industrial cluster, that's a perfect opportunity. So yeah, the answer is there are places where logistically it makes more sense to do CCS. There are other places where politically and there is a bigger incentive to do CCS. I think Canada maybe is a good example because they have a carbon tax, so they are really implementing CCS because that's convenient for the companies. So yeah, there are also places in the world where probably it's difficult, where there is no storage, for instance, or where there is not enough CO2 to be captured and transported to a storage, and that wouldn't make sense even with a good incentive probably. So yeah, that's my answer to the first question.
Any further comments on the second question, which was about contracts?
No, so I think it is indeed public and private partnerships. In the end, it is the governments who own those emission reductions. And if they are not able to make effective market mechanisms, which really will realize and deliver that somewhere down the road, those reductions will not be met. And so I think it's really for the governments with the private companies working together on this. And I think here in the UK, quite a lot of work has been done around how that could work. So I think the UK is very endowed with the insight of it for all the different activities that has been done. So they can take that and create that further. But I think the government is in betting order now on trying to create those industries going forward.
Just to elaborate on that a bit further, I think, and touching on the gentleman right at the back's question, I agree the commercial challenges are well known, and a lot of them are the same ones that have been around for 15 years. But I think politics shifts, what industry needs shifts, and market shifts. So, we've had numerous administrations since then, each trying to deliver slightly different political priorities. We've had things like falling in oil price, we've had movement in gas prices, we've had China dumping a load of steel on the market. These sort of fundamental market drivers change all the time, and the requirements of industry change. So, each time a policy is developed and we go through a 4-year competition process that's then cancelled at the last minute, that changes people's appetite to invest, and we've been through that numerous times now. And anecdotally, one developer said to me that it would take an irrevocable and unconditional, irrevocable commitment from government in order to get them back to the table. And whilst I don't think that is representative across the board, it gives you a sense of just how some of the developers feel about the efforts they've put in so far. So, again, coming back to what Wilfred was saying, it's really important that we actually move away from this mindset where we've just said, let's start a competition and see what happens, and we actually really focus on delivering something that's collaborative between industry and government, perhaps a bit more open book, and get a really good understanding of what the issues are and what's on the table to try and address those things.
Okay, in the interest of time, I just want to take one more question, and this gentleman here has been very patient, so you'll be the last question. And I know there are other questions, but I'm sure the panelists will be at the networking session, so you can ask the questions. Okay, so
Paul Lawrence, ex-technique and now independent consultant. I'm interested in priority number 8. How is decoupling of power generation from CCS capture improve the case for carbon capture, surely the power plant is very efficient already. Like for example, CCGT, natural gas requirements, already exceed 62% efficiency. It's the capture that brings the power plant down. It reduces its efficiency, it increases its capital cost, it increases its cost of electricity. So surely anybody who wants to invest in carbon capture projects, for example, government, if they want to fund it, project financing, they all want to look at overall cost of the project by decoupling. How is it going to improve CCS?
So I think perhaps that could have been better worded. Needs a comma. So the point is that right now, the way that the projects have been developed was you have to build a power plant and a capture plant and a pipeline and storage. I just want to burn some fossil fuels and make electricity. Now that's a business that I understand, and that's a relatively simple thing to do. So the point here is that doing all of this together in one project with one sort of balance sheet or one group of people is hugely complex. And you then say, well, okay, and the cost per megawatt hour of the CCS electricity from all of that is a big number. And I think, as was discussed earlier on, what you want to, what might be a good idea would be to have, well, okay, there's a national storage operator who will sort of go and do that, and I can provide storage at X pounds per ton storage. There's a transport operator, perhaps you can transport CO2 for X pounds per ton, and that's a separate business. And then finally, there's the, okay, I'll provide decarbonized power and a source of CO2. So you break it up into kind of more manageable chunks. That was something that came out of our discussion. Does that make more sense? So it's not about sort of breaking them down technically, it's breaking them down commercially or attractively. Does that make more sense? No, insert it.
So, two quick remarks. I think I completely agree with what Niall was saying. I think this is really about the benefits that you get from shared infrastructure. So there's two aspects of that. One is in terms of giving a true reflection of the costs and the value of that infrastructure. So as Niall said, competition projects were asked to commercialise an industry. They weren't asked to deliver the single cheapest project. And the White Rose project, for example, has confirmed that the unit transport and storage costs for Project 2 would have been 60 to 80% lower than they were for White Rose first project. So that's just the difference between Project 1 and Project 2, 60 to 80% reduction in unit costs of transport and storage. The second point here is more of a commercial point, and that's around cross-chain risk that I talked about earlier. So delivering these through a single integrated value chain meant that the CFD revenue had to flow right down from the generator through the transporter to the storer, and actually the issue of what would happen to, does the storer still get paid if the CO2 is not delivered from the power station and vice versa. And those sorts of commercial risks actually were a fundamental challenge that competition structure didn't address.
And I think one thing to highlight is that the capture plants are very integrated with the power plant. Both from ducting, for steam, for cooling water, and you name it. So I think that a comma is needed because it is a clean power plant, which creates a stream of CO2, and there you need to make this separation to make an effective business model. And if you try to make a business model saying, well, you need a power plant and then you need a capture plant and all the interfaces, I think then you lose a lot. So I think it's a clean power plant plus a CO2 infrastructure.
Okay, thank you very much. So I think we'll leave it there. Before we thank the panel, I'd like to thank you all for coming tonight and for your attention and for your questions, and also for people listening to the webinar. Thank you very much for joining us. My key take-homes, as I discussed with Malcolm over there, perhaps some clear communication from the IChemE Energy Centre on what could be an attractive proposition for the government. The government owns emission reductions, is what Wilfried said, and so that sounds quite a good way of leading the discussion about PPIs. And the low-hanging fruit, of course, as chemical engineers, we all know about the T side, and certainly that's a great place to have some cluster action on carbon capture with some utilisation as well. So can we thank our panellists for their contribution? And I've just put this up again. If you want to join us and help us with these kind of studies, then please contact us at that email address. We now have refreshments in the room next to this one, so please stay, help yourself to the refreshments and have a chat with us about what you've heard tonight and your interests, and it'd be good to meet you. Okay, thank you very much.